So for example, this is like a dictionary, student dictionary, and it has names like keys and its associated values. And this is similar to a list like items, but in a dictionary, the items are divided by key and its associated value with a colon sign, right? And how you can access the dictionary, I'm just recapping. Student, if you'd like to access, for example, GPA, you need to use this well by the key. But for the list or tuples, we can use the index. In a dictionary, we are not using an index. That's why we need to use a key. And key should be unique. So GPA and this GPA are different. They are case sensitive. So if you're writing GPA, you'll have an error. What kind of error you'll find here?
Null error.
What error?
Null exception.
Null exception. What else? Key not found, like key error. Key doesn't exist. Yeah, null can be found in different language, but in Python, it's like specific type of error, key error.
Gotcha.
Key doesn't found. Okay. So to avoid this type of situation, we can use the get function. So if we're using student.get using the GPA, like the keyword, then if the key doesn't exist, we don't have any error. Rather, we'll have what? What did you return? Oh, well, definitely it will return a none. Instead of an error, it will return a none. That's because there is the key doesn't exist here. But if it is there, then it will return the exact number. You can specify here like, well, if the key doesn't exist, I need to return a different thing other than none. For example, like I would like to, like by default, the GPA is like 2.0. So if the GPA is not there, then it will return 2.0 instead of a none. This is like a default value. Okay. This is for the get method. What other methods I have mentioned here? Where's the methods? Get set default. So set default returns the value of a key. If the key doesn't exist, it insert the key with a default value. So if you're writing like set default, if the key doesn't exist, it will add that key to the dictionary with a default value. Okay. But I will show you how you can solve this problem in other way using a default dictionary function, but I will go those things later. What other function I have mentioned here, like keys? Keys will return the key of a dictionary. So student.keys will return the keys of the dictionary, but the return type is not a known type. If you're just printing, then it is not a list or tuple or a dictionary type of data that we are used to. This is like a dictionary keys type of data. So you need to convert it our known type, like a list or tuple, whatever you want. If you're returning by the list, it will return as a list of keys. How you can iterate a dictionary? You can iterate a dictionary using a loop for a student. And if you're just iterating the student, by default, it will iterate by the key. So key in student. If you print key, then basically it will print the keys. You can also use dot keys, but it is redundant. You don't need to use the keys. By default, it takes the keys. Some other functions are like values. It will return the values of a dictionary. So this is not a key, then this will be like a value. But typically, we are not iterating a dictionary by its values, as because the values can be duplicated, but keys are not. You cannot find a key of a dictionary from its value, but the reverse is possible. If you know the key, you can find the value. But if you know the value, you cannot find the key. So that's why I strongly suggest you to use the key or a tuple. Item is like a tuple with key and its values. And as I told you, the items is like a packed tuple. Do you remember the packed tuple, packing and unpacking? They are packed in a tuple, so we need to unpack it. We are unpacking it with two different values. So there are two items here, like each time it has two items. So if I just print item and print the item here, so it will print each item at a time, which is like a tuple, key and its associated value. So we need to unpack it by two values, key and value. Then you can use the key and the values. This is the key, and you can use a value here. The key and their associated values. This is how we can iterate a dictionary. I already have told you, you can use an enumerate function. Enumerate function will give you. What is the enumerate function? It will iterate a list or tuple or dictionary and with its default value. So its default value is 0. So it starts with 0. Then next onward are the successive numbers. But you can always modify the number to a different number. Like for example, you're starting from 100. It will start from 100. Then next onwards are the successive numbers. Okay. So keys, values. What else? I already have told you about the clear. Del, how you can delete from a dictionary. So clear is like clearing a dictionary. Del is like deleting a dictionary. So if you're just using a clear, still you have the dictionary, but nothing on there. But if you're using a del keyword, it will delete from the memory location. Then pop and pop item. So pop will return the last item, and pop item will return the, actually pop will return the, remove the last item and give you the last key. But pop item will do the same thing, but give you the key and value pair. So typically pop item is a better choice. Okay, from keys. From keys is a type of method that you can use to create a dictionary from a list or tuple. So for example, here is our keys, ABC, and we would like to create a dictionary from the key. Now, here is our keys, like 1, 2, 3. And if you'd like to create a dictionary from the keys, there is an error. That means you cannot convert a list to a dictionary by the dictionary function. So in that particular case, you need to use the from keys function. From keys function, create a dictionary from a list or a tuple. But you can see here, the default values are none. You know the key, but you don't know the values. You're providing the keys, but not the values. That's why it gets the, it provides the none value as a default value. You're going to specify here, like, well, the default values are 1, not 0. So you can modify it here, like for one key, the value is 0. For key 2, the value is 0. For key 3, value is 0. Okay, but unfortunately, there is no function to create keys with their associated value, and they are listed in two different lists. You can create a dictionary from the keys only with a default value. Later, you can change it. Okay. Any question? Okay, now we have a dictionary here, student. I would like to copy a dictionary. Copying is really important here. So what we have done previously, like this is my value 10. If I would like to copy this value, I can create another variable val1, and I'm going to copy this one. Right? This is what we have done. We can use the same assignment operator here to create a copy. So this is student copy. Okay. So this is my copy, student copy. And I would like to modify its GPA to 4.0. Okay. That means for the student dictionary, the GPA is 3.8. For the student copy, GPA is 4.0. Let's see what's inside the student dictionary and what's inside the student copy dictionary. Both are getting 4.0. Do you know why it is happening? I only have changed the copy one, not the original one. Where, Gavin?
The copy is replacing the value, so it's becoming like a fill-in for the main, what is it called? So sorry.
Yeah,
I'm
go ahead.
having a brain fart.
It's fine.
It is becoming the it's not a list. What is it called?
Dictionary.
The dictionary.
Yeah.
Yeah, it is becoming the dictionary. So it's replacing it instead of creating another copy.
Okay.
And then replacing it.
Okay. Any other thoughts? You good?
It's similar to like what happened with the lists. It's pointing to a place in memory, and so it's taking a place. It's like how lists were places in memories. You're assigning it to the place in memory instead of the dictionary itself, and that's why it's happening, right?
Yeah, that's the actually main reason. So whenever you are assigning, it is not creating a new dictionary. It is just referencing the old dictionary. Like if I can draw something here, like here's my memory location. And here's my dictionary. And as I told you, dictionary are not ordered. So name can be here. And then the major can be there. Maybe the GPA is here. And year is here. So there are like 4 keys of a dictionary. So here's my dictionary D1, for example, or student. And there are like 4 keys. One is here, there, here, and here. 4 keys. They are not ordered. They can be stored in different location. When I am copying another dictionary, student copy equals student, that means that student copy is not creating another dictionary here. Rather, it is pointing to the old dictionary. That's why if I'm going to change to the copy dictionary, eventually it changes to the original dictionary. It is not creating a new memory to the memory location. Rather, it is pointing to the old memory location. Okay. So either way, if we are just changing to the student one, it will change to the new one. That's because they are pointing to the same memory location. Now, how we can solve this problem? Maybe I would like to create a copy of the dictionary, then I can modify it, not modifying the original one. How could I do that? Well, before going to that, I would like to know the memory location of those dictionaries. How do I do that? Hash. Okay. Let's see what it returns to the hash. You cannot hash to a dictionary. What other function that you have used to know the memory location of a variable or dictionary in this case? Remember? Roman? Okay. No, I thought you were just thinking. That's why I'm just asking.
I was trying.
Okay, it's the ID. So if you're using the ID, then it will give you the memory location of that particular data structure. I can see for both cases, the memory location is the same. It means even if it's a copy, it is the same memory location, just pointing to the old dictionary. Well, there is a function called like copy, dot copy. We can use that function to copy. So I would like to create a copy of the dictionary and then print the student cop. Let's see if it prints. Well, it copied. Then probably we can modify student copy. Now we change. So I just created a copy of the original dictionary student copy and modified the GPA for that copy. Now for the student copy, I have the 4.0 on the second line. For the first line, it's a student. Okay. Any question? Okay. Before going to deeper in the copy, I would like to discuss about the nested dictionary, like nested list. I hope you are not happy with the nested things, right? So nested list, nested tuples, now nested dictionaries. Nested means like list within a list, tuple within a tuple, dictionary within a dictionary. Instead of one student, if you have like multiple students. So let me write here, like I have multiple students. So this is my student one. There's something there. And this is student two. Something there, right? This is like a single dictionary, not the nested. I have a student one, something there, student two, something there. But in this case, for the student one, I have all of those information, name, major, GPA, and everything. That means I need to create a dictionary for that particular student. You don't need to use the indentation here. It is for like visualization purposes. Like you can easily see what's under what. But you can just write everything all together. For example, like this way. It is hard to read from there, right? But it's the same thing. That's why we're using indentation. Okay, this was student one. I can do the same thing for student two. This is student two. And since it is student one, I need to use a comma. This is for the first item of the student dictionary. And this is for the second item for the student dictionary. And for the student one, it is also a dictionary. In that dictionary, this is name, major, year, and GPA. Same thing for year. Ariana Grande. Spelling grand.
Yeah, sorry, Grant.
So computer science, maybe electrical. Year 3, 3.9. There are like 2 students here. And this is basically a nested dictionary. Now, how you can access a nested dictionary? Well, this is the main dictionary, students. And if I'm going to access a single item, like S2, it will print the grand dictionary, right? The grand information. But it's a dictionary. If I would like to know the name of the S2, so this is the first level. How we can go to the second level? Like our nested list, nested tuple, we can use another square bracket. But for our list and tuples, they're only numbers, that's because they are the index. But in our case, we don't have the, in the dictionary, we don't have the indices. We have the keys. So for the first dictionary students, the key is S1. That's why we're getting the whole dictionary. Now in that particular dictionary, I would like to know the name. So in that case, I need to use a name as a second keyword. The first keyword will give you the whole dictionary. The second keyword will give you the particular key of that dictionary. Now we'll see the name only. Okay. Is it too complicated? A little bit, but it's okay. Okay. Now, how we can iterate a nested dictionary? Do you remember when we have iterated a nested list of tuples, we have used multiple loops, right? Loops within a loop, like loop within a loop. Same thing for the dictionary. Within a dictionary, we need to use the loop within a loop. So for the first one, I can use this. This is my first. So let me print this one first. Print the student. Then it will print each student information. The S1 and S2. S1 is the key, S2 is the key. That's because the student will iterate by its key, right? Now, if I use the key student dot items, then probably this is my key and the value. So for that particular key, I have that value. For that key, I have the whole value. Again, that value is another dictionary. That means we need to iterate that value dictionary again. So what I'm going to say here, like this is key, I'm saying key 1, and this is like a, I'm going to iterate that key 1. In that case, it is like a key 2. So not the items, so that it will return only the keys. So this is key 1, and this is key 2. So you'll see for S1, you'll see a lot of all of those 4 keys. For S2, you will see all of those 4 keys. If I print it here, you can see for S1, so key is a dictionary. So value is actually dictionary, not the key. Iterate through the values. So for the S1, name, year, major, GPA. Same thing for the S2. That means every time you'll see S1, that means for one key 1, it will iterate all of those keys. Then it goes to the next key, then all of the iterations for that S2. That's why you are seeing 4 times S1. As because key 1 still there, iterating 4 times. That's why you're seeing name, major, year, and GPA. Then go up, go to the upper level. S2, name, major, year, and GPA. And from there, if it is like an item or items, then you have a key 2 and value 2. But for one key, this is my key 2 and the value 2. So I can use here a colon. So for S1, this is the name. For S2, this is the other name. The major is computer science for S1. For major, for S2 is like electrical. So this is how we can iterate a nested dictionary. If it is like a three-dimensional dictionary, like, well, someone have multiple majors. It is like electrical engineering and computer engineering. Now you can see here another dictionary for the major. If I would like to iterate that one, then probably I need to go another level down. For the val2, or key 2, if the key 2 is equal the major, then print the list, or you can iterate it again. For I can write here two conditions as you see here. The key 2 major is here and here as well, but you need to find out like if key 2 is major and key 1 is S1, S2. If the key 1 is S2 and key 2 is major, then we will iterate. Actually, it should be key 2. So print MA. This is like a third level of nesting. For the first level, for the first one, it is okay. For the second one, what I need here, key 2 is the major, so it should be val2. We're actually accessing the dictionary, not the key. So dictionary is in the value here. So previously we have iterated through the keys. That's why you're seeing all of the strings. Does it make sense? Any question about the nested dictionaries? Now, some of my students ask me, why do we need to use a nested dictionary over a nested list? Or a list of dictionaries. Instead of a nested dictionary, I can use a list here. I have a list, and each item is a dictionary. So now in that particular case, I need to use not S2, I need to use index so that I have the first item. First item is a dictionary, so I don't need to use a key here. It's a dictionary, it's another dictionary. So it will print the second name, the first name, Ariana. Can anyone tell me what is the difference between those two? A nested dictionary versus a list of dictionaries.
And keys in a
Keys.
nested dictionary.
Yeah, definitely.
You have
Keys.
access to those.
Keys is the keys. So what other thing you can think of? So in case of accessing a list, you need to iterate from the first one, right? But for the dictionary, you don't need to. You can jump to the GPA, jump to the major if you know the ID. You don't need to go through name, major, ER, and GPA sequentially. You can jump anywhere. But if you'd like to access the last item of a list, you need to iterate from the first item. It takes longer time. That's the main difference. Okay. And also the main difference is like the bracket, square bracket versus curly bracket. This is the main difference. Yes, Gabe.
Would the list also be like, if you wanted to keep it so nothing got changed in there, you would want to do it this way and not the list way? Because
Like the copy. things you're mentioning or what?
Like,
If it's a
um,
list. Okay, this is like a list right now. Now, what's the question?
just kind of making sure, like, when we talked about the lists, those are immutable, and then the dictionaries are, or is it the other?
Actually, list and dictionary both are mutable.
Okay.
Yeah.
I'll come up with a clear question now.
Yeah, if it's like a tuple, definitely it's a different things. Okay. But list and dictionary both are mutable. But the only difference is like accessing time. In case of accessing a list, it goes to the first item first, then they iterate sequentially. But for the dictionary, if you know the ID, it will just hash and go to the direct location, memory location. Okay. But you can ask me a question later, don't worry. Okay. Now going back to the copy. So student copy. Initially, we have used this one, right? But it doesn't work. So we have used a copy. It worked previously, right? And let's see if it is working now. I would like to use a copy, like, and to change the grade. Let me write it differently. So maybe the major. It has like, okay, try with the GPA. It's like 4.0. And now print the student dictionary. So I'm going to change actually S2's GPA to 4. It changed to the 4 because I am going to directly to that particular location. But let me see an exception. Maybe going to this one. I'm going to here. So I'm copying it and changing to the fiction's first item. It could be a dictionary within a dictionary. It doesn't matter. Not necessarily it should be a list. It can be a dictionary. So both are mutable. It doesn't matter. So in that particular case, how do you access a dictionary here? It should be a list, as we don't have any key here. So what we're going to do, we're going to change the, so I have a library 1, I'm copying it to library 2. Now I'm going to change the fiction of library 1's first item. So first item is 1984. I'm going to change it to Brave New World. Okay. That means library 2 is intake there. And see if we have the same or different thing. I changed 1984 for library 1. So this is the library 1. It changed, but it also changed the library 2. I haven't changed library 2. We have used the copy, dot copy, that what I've mentioned previously, that don't use the equal sign, use the dot copy, then it's solved. It's solved on that time, but now it is not working. Do you know the reason?
Because the lists are still being referenced.
Yes, that's the answer. But if I'm going to get, so it could be anything, like not necessarily list, it could be a dictionary, it could be tuple. not the tuple. The tuple is not mutable. Dictionary or list. The same thing. List is referencing. Dictionary can be referencing. But the main concern is like if we're using a nested things in a dictionary, the nested one is referencing, not the top one. That means if I'm going to change a new one, like for example, I'm creating library one, another type of book like non-fiction, and it is like not the sapiens, like Homo and whatever. Genius. That means I'm changing library one, not library two. Now you can see for the library one, I have the non-fiction, but it is not there in the library two. But I've changed the fiction 0, it changed in both cases. It's complicated, right? That means in the dictionary, the top level is not referencing, but if it is like a inner level, like nested level, they are referencing. This is called like a shallow copy. Whenever you're using dot copy, basically it's a shallow copy. It works for a single dictionary, but if it's a nested dictionary, it will not work. Now the question is like, is there any way that you can solve it? Yes, there is a way. The way is deep copy. If you're using a deep copy instead of a copy, then it will create two different instances in the memory location. Now it will not change. For the deep copy, it should be another library function, I guess. So copy dot deep copy. So syntax is copy dot deep copy, and inside the deep copy, you need to use that variable. Now it changed on the library one, not the library two. This is like a real copy. But if you're using dot copy, it may work for the top level, but not the nested level. You need to keep in mind. Any question? Given?
I think it finally clicked in my head.
Okay. Well, before going to deep copy, if you'd like to know, well, I would like to see why it is happening. Why I have this problem. I have changed to library 1 fiction 0. It changed to library 2 fiction 0. So let me see what is the ID of those two things. ID of library 1. The ID of library 2. They're two different things. They're in two different locations. Let me see what is the ID of fiction. Like a nested one. That means they are sharing the inner one.
Because you didn't update it, is that why it's sharing that same memory?
Like in dot copy, they are sharing the inner one, not the outer one. Like, so first thing is like, if you're using equal, it will share the whole thing. If you use the dot copy, it will not share unless it is nested. That's why you can see here the nested one is the shared one, referencing the same thing. But if you use a deep copy, they're not sharing. two different things. The nested one is not the shared one. You can see this one is 44 and 84. This is the way you can investigate whenever you have any situation, this type of copying situation. The ID is the very powerful function in Python so that you can easily find, well, what's happening if you are seeing, like, you are updating something, but it is not updating, or you are updating one thing, it is updating the whole thing. The ID is the best function to know. So you need to remember it. Okay. Any question about the copy thing? So the key things are here. First, use the equal sign. Definitely it will create a copy, but they're referencing. Dot copy will create two different things, but top level, not the inner level. If it is not a nested one, don't worry, you can use a copy. If it's a nested, then definitely you need to use the deep copy. Because in case of a nested, they're sharing the inner location, inner dictionary, inner list. It could be applicable to the nested list as well. Okay, so let me see. I already have discussed the different types of methods. From keys, nested dictionary, copying a dictionary. This is like an important things. Now I would like to go back to the default dictionary things. What is a default dictionary? Default dictionary is a function from a library. The library name is collections. From the collections, you can use that function, which will create a dictionary for you. So far, we have used did function and a curly braces to create a dictionary. There is another function called like default dictionary, but default dictionary is not a built-in function. That's why you are seeing there is an error. That means you need to import collections. Collections is a library. I think I have missed this information, how to import a library function. Did I? It should be in the module 3 or module 4, but I think I missed it. How you can import a library. Or maybe I told you when we use the math library function. What is the library and what's the built-in things? The built-in thing is like Python has its own functionality. And what is the library? Someone created a library for you, you can use it. Like a math library. Python doesn't have the tangent function, like a tan function or sine function, but the math library has its. So that we can use the math library function. It has its sine function, we can use it. So in that particular case, the did function is a built-in function in Python. We don't need to use any library function. But the default dictionary is not a built-in function. It is a library function for this particular library, import collections. Import collections means like you're importing everything from the library function. And in that import function, the default dict is a function. Now there is another way to use the import. You can use from collections import default dict. That means you are not importing everything, just that function. What does that mean by those two different things? So the first one, if you're writing this way, it will copy the whole code of the library at the top of these lines and then start working from here. In the second case, it is not getting all of the items, just the default function, default dict function. So definitely in a larger code, if you're just importing everything, it will take longer time. But if you know you need to import only the default dict function, then just use it. Or you can use an asterisk sign, which is like you're importing everything. Okay. So for the you need to use this way, collections dot default date. So there are two different types of syntax. If you're importing everything, maybe you have your own function in your library or in your code. In that particular case, you are actually looking for the collections default date function. But if you're using from collections import default date, then you can only use default date. You don't need to use the collections here. Because you are just importing that particular function. If you're importing it, you need to specify it like it is a collections default date function. Okay. Okay. Why do we need to use a default date function? Well, as I told you, the key error, if the key doesn't exist, then there's an error. We're accessing some keys, but the key doesn't exist. Then we have an error. To avoid this type of situation, we need to use .get method, then definitely use our validation things like our conditional validation, like whether this value is there, then do these things. But you can use the default function so that if the key is not there, it will create for you. In the default date, the syntax is default date, the default factory. The default factory is a function. If you're using integer, it will create an integer type of value. If you're using a list, it will create a list type of value for the values. So let me write something here. So default dictionary, I'm creating a dictionary D1 with the default dictionary in an integer. That means I have a dictionary D1 where the values are only integers. Now, if I'm going to access an item like print D1 grade, we don't have any error. This is 0. The default value is the 0. Sometimes we need to increment the grade. So what I'm going to do here, I'm just writing the D1 grade plus equal 10. If I'm going to grade to 10 points. Now, if I'm going to print the D1 grade, it will increase by 10 while the default value is 0. But instead, if we have only the dictionary like this, definitely we'll have an error. The grade is not there. So what you need to do, we need to use an if statement like if the D1 dot get dot grade. If it is not there, then you can use D1 dot grade to 0 first and then increment it by 10. If it is not there. So instead, you can use the default date function. So you don't need to use anything here, not the list, to be integer. Now, I told you, like, if we have like multiple items in a list key, for example, like here's my dictionary and here's my grades. I have 10 points. If I'm going to add another grade for that particular dictionary, it will overwrite, right? Typically, it will overwrite. So what we have done there, we have used a list. Then we have used dot append so that it will add to there, right? This is what we have done naively. But if you're using default dictionary, then you can use the list here. You don't need to worry about anything. So this is my D1. So D1 is my dictionary. The list type of dictionary, and where the grades item is a list. I have used here the list function so that the keys should be list. And the good thing is, like, if you're using here like a name, so the name is the John is not a list. So whenever we are appending it, it will create the issue. Whenever we are using an append function, it will act as a list. Whenever we are assigning, it acts as an item. You can see a list as a value and a value as a value. Like the value means like a general type of value, for example, string, integer, float. Okay. So that's the benefit of using default date function. Whenever you have a list of values for a single key. Other than that, the regular one is fine. Any question about the default date function? Okay. Okay, here's what I have shown here. Why do we use it for grouping a list? We can use the list. Okay, I already discussed the nested dictionary. And why do we use a nested dictionary? We need to use a nest. Oh, okay, one thing I have mentioned here, I forgot to mention here, is like where's our nested dictionary here. The print students. It is like a dictionary, right? But how do you know whether the GPA is under name or S1? Or GPA is under the first level key or the second level key? It is tough, right? There is another type of printing which is called like pretty printing. Pretty print, I guess. Let me see the syntax. Pretty print. P print actually. P print. If you're using P print dot print dot P print, you can see a nested dictionary. I think this is not the right syntax. Let me see. So it shows here like this is the first level, this is the second level, but it is better to use a different example. Have you heard the JSON? Not a JSON. It's like JSON. JSON is like JavaScript synchronized something. I don't know the exact thing, but it's like JavaScript. Typically, we're using JavaScript in web languages. So in that particular jQuery or JavaScript, we are using a specific type of data. This is a well-known type of data, which is called like a JSON data. Whenever we are sending our data from one place to another place, like one client to server, server to client, we're using a JSON format. So you can use the JSON format to crawl the data. So here's an example using the JSON format. I'm going to crawl a data. Oh no. What's that? Copy button. Allow me to print. Oh, okay. I use control, alter. So what we're going to do here, there is a library called request. With that request, I'm requesting that particular URL. What's in that URL? Its URL is these items, JSON data. So preprint, you can see here preprint. From the preprint, we can just crawl the data, and then so here's the URL. Request.get is a function, provide the URL, and you're accessing all of those things. And then you can use the .json. And this is our function geocode. I'm going to find the India gate for that address to the JSON, and it will give me the JSON.json, give you the result, see what's inside there. I need to use a preprint to print it. So data, so not the print, preprint dot preprint data. You can see that information in a nicer format. But if you're not using preprint, just the print, typically JSON are multi-dimensional data. So you can see here, like, this is the first dimension, like top level. Then the second level, I don't see any second level here. We find a large JSON data. I'm looking for a good example of large JSON data. Typically, JSON data newspapers are providing those type of JSON data. For example, like this is the JSON data. There are a lot of information, status, for the article, is the list. Then in that list, there is a dictionary, that particular dictionary, there is another dictionary. So the like multiple layer of data. Though it's the nested type of things, but multi-layer. If you're just printing like this way, then it's really tough for you to find out like where is the description? Is it under article? Is it under this dictionary or the top level? It's really tough for you. That's why preprint is really a good way to visualize your data. And most of the websites are providing preprint, not the website, the web browsers. So if you go to that particular location, like Google Maps, you can see there is an option like preprint. I don't see any difference, but in case of a large data, you can see this like first level, this is the inner level, what we have written here. Like this is like our first level, this is the second level. And if you're writing another level, so this is like a second level data. Okay. Okay, so We're about to finish on the dictionary. Just the one last thing is the dictionary comprehension. Again, I don't think you like it. The comprehension, right? The nested things and comprehension things are two. The most complicated part in Python. This is like an intermediate level of skill. Eventually, you need to learn it from this class. So comprehension, do you remember the list comprehension? Or the tuple comprehension? List. I need to iterate a list for, maybe I need to increment that list. So this is like added list. I need to iterate that list for item in L1 and item in L1. And then like this, I'm going to iterate add by 10 and print it here. It will create a new list by adding 10 to each of the items. Do you remember the list comprehension for this particular operation? List comprehension. I'm going to create this list. What I'm going to do, I need to create a list, right? This is my loop. I'm going to iterate an item for item in L1, right? And then item plus 10. That means every time I am iterating that particular list and what, so what is the value, whatever the value, 1, 2, 3, 4, I'm adding by 10 and then creating a list at the very end. That was the list comprehension, right? As I told you, this is like an intermediate type of skill. But you need to know this naive way. If you don't know the naive way, you cannot write the, if you don't know the naive way, you cannot write the list comprehend way. So this is the naive way. Now the dictionary, same way, you need to know the naive way, how you can iterate a dictionary, how you can access through it keys, values, or items. Then if you know it, you can write the dictionary comprehension. What is the syntax for the dictionary comprehension? Key expression, value expression for item in iterable. This is the same for our list comprehension, right? Our iterable was here a list. In that particular case, we have the dictionary. Let's see with an example. A lot of examples here. Creating a dictionary from a list of tuples. So this is a list of tuples. How you can create a dictionary? Well, this is our character K and V, K to V. Now, if I would like to create a dictionary from a list of tuples, how could you do that? This is our dictionary, like list of tuples, right? How we can create a dictionary? Well, this is our dictionary D1. And then for item in the characters, right? So the item is like a tuple with the packed version. So we can unpack it by, what are those actually? Mario, platformer, Link, adventure, Kirby, action. Okay. Name versus maybe occupation. Okay. Then I need to create a dictionary. So this is our dictionary D1. For each name, I need to create a dictionary. That was the name way, right? Creating a dictionary from a list of tuples. We're writing the same thing here. For whatever it is in the character, there are two items. It shows like key and value, and you're writing key colon value for the dictionary. Here's the dictionary with the curly braces. This is the dictionary comprehension for the creation. What are the other thing? Creating dictionary from two separate lists. I have two separate lists, not nested right now. How we can create a dictionary from two separate lists? Well, it is easier to zip. So if you zip it, then Mario and Platformer will be merged together as an item. Link and Adventure will merge together. Kirby and Action will be added together. So we're zipping it. Then we're iterating to the zip to the key and value, then key to the value for the dictionary. This is like a two separate things, unless it is nested. Probably you don't like the nested things. So this is the nested things, and this is not the nested one. But eventually with the zip, we're nesting it. But we're not worrying about those things, what they're doing inside the zip function. Filtering for the dictionary comprehension. This is our dictionary, but I'd like to filter only with the action. Like this is our main dictionary. I'd like to create a new dictionary, which will filter only the actions. Whenever the values are action, I will create a new dictionary. So I'm creating a dictionary with the curly braces, and here I am iterating with the item. And we're creating a dictionary. If we don't have the if statement, it will copy a new dictionary, right? With this particular filtering, we are only copying whenever it matches with that the value. Whenever we have the values, we are just creating a dictionary. Or we can create the dictionary in the other way. Whenever it's not a value, like it's not the action we're creating, like whenever we have a duplicate value, we can discard it. So whenever we have a duplicate item, we can discard it. So we have the platformer, adventure, and platformer here as well. If not action and is not equal platformer. This is like a filtering dictionary, creating a dictionary with filtering. Transforming value in a comprehension. Transforming value, what it is doing? It is just accessing the item, but each item for each item, we are converting that value to the uppercase. So right now we have a lowercase value, we can convert it to uppercase. Sometimes you can use the lowercase one so that you can check it for like different types of checking mechanism. So you can use like dot lower here. We are creating a new dictionary with the same item, but converting the item pattern. Okay. That's all for the dictionary. Next class, I'll be discussing about the sets, which is like a part of dictionary, but it is different types of data structure. Any question about the dictionary? No?
Are there